welcome to AWS's Howdy Partner. We are here today with some friends from Fiddler AI or Fiddler Labs. It's going to be a great episode. Everybody, it's going to be a lot of fun. I think this is actually our last episode of the season, but stay tuned. You might see some Howdy Partner stuff at reInvent too, which is coming up with a vengeance. I'm A.M. Grabelny. I am joined by my friend up here, Young. We are both employees here at AWS, and we love the Amazon Partner Network, which Fiddler is a part of. Young, what is the Amazon Partner Network? Or AWS Partner Network, actually. I got it wrong.
Hello, everyone. I guess first introduce myself. But to answer your question, I almost said APN myself. AWS Partner Network is a network of partners that we have here at AWS. I guess I just spelled it all out there. But basically, we have partners in many different industries, such as Fiddler AI from ML, where we help them get more customers in their AWS solutions, and it's a partnership in part because we help them get more customers, which in turn gets us more customers. So I guess that's my 2-minute explanation there.
Okay, I like to say that we've got a lot of tools here at AWS that you can work with, and we don't do everything though. And our partner network really helps us expand out and work alongside with these companies to deliver opportunities and capabilities to AWS developers. So if you're watching today and you're very interested in Amazon SageMaker, which Young is going to give us a little rundown of in just a few moments, stay tuned for Fiddler too, because Fiddler does some really, really neat things with Amazon SageMaker and ML in general. If you have never watched Howdy Partner, it's a show for everyone. If you're interested in technology, if you're learning, if you're an expert, everyone should be watching. I don't know very much about ML, I'll be honest with you. So I'm hoping to learn from our friends here, Christian and Manoj. Do you two want to give a quick introduction, and we'll learn a lot more about Fiddler here after Young's SageMaker demo. But Krishna, you want to tell us a little bit about yourself, and then Manoj, please?
Absolutely. Thank you, AM and Young. I'm Krishna. I'm one of the founders and CEO of Fiddler. We are an explainable AI platform startup in the Bay Area, and we are super excited to showcase Fiddler and how it can help, SageMaker and the other MLOps community to build trustworthy AI applications today.
Hi, I'm Manoj Srinath. I'm a co-founder and the chief architect for Fiddler. I'm glad here to show you guys some demo.
Cool. And as is tradition on Howdy Partner, we've got hands-on demos all day today, right? So everything that you're going to see today are actually working demos and things in ways that you can start getting to value with SageMaker and with Fiddler. So I'm going to shut up and I'm going to let Young take it away, because Young is going to tell us all about SageMaker, which, my understanding, it's intended for people like me who maybe want to learn more about machine learning, how to operate in a Jupyter Notebook environment. Maybe you're a data scientist. You've got a lot of experience. Maybe you're not. I think SageMaker helps with a lot of these types of different personas. What would you say, Young?
Yeah, so let me take it from here. Obviously, AM has kind of set the stage here a little bit, but ML, machine learning, and to a certain extent, AI has become a pretty big topic in a lot of industries of the ways it could influence business, from business decisions, making predictive analysis, and just it's starting to become ingrained in a lot of business practices, basically all over. And as a regardless of how big your company is, there's a lot of talk of developing an ML practice or creating an ML team, pipeline process, and a lot of discussions around ML. And if you take a look at it in a little more detail, the process of developing, notebooks or, even a simple code and being able to run it on the resources that you may or may not have sort of becomes a convoluted process. So this is sort of what the problem that Amazon SageMaker is trying to solve, is giving a platform or providing a platform for users of various degree of knowledge in the space, an ability to kind of build your model, train it, and deploying it at a scale that that is very convenient for the users. SageMaker itself, I will be honest with you, SageMaker itself, I don't know every little detail about it. Obviously, there's a lot of things that's being offered as part of the whole package, and hoping to show you viewers a little bit of how it works through a demo that I have today. So
I remember when SageMaker came out, Young, and it was relatively, I'll call it simple. It was mostly a hosted Jupyter Notebook environment, but it has since exploded. There's so many features now around SageMaker. It's pretty interesting, I think.
Yeah, no, I mean, like you said, you could make it as easy as just uploading your own notebook and then having it hosted and running it. There's other things and features that you can use to kind of make your life a little easier in terms of, deploying endpoints for inferences, auto ML, which I guess I'm just about to demo to you guys, and even things like ground truth, which helps you label your data. So
let's see it.
Without further ado, let me share what I have. And hopefully everybody can see that okay. Let me know if I need to zoom or anything. But this is a console look of our SageMaker service. As you can see, it tells you it's meant to build, train, and deploy machine learning models at scale. There are different features that you can kind of look at. We are going to start with Notebook. And I already have a notebook instance created, but you can also create your own notebook instance. Let me just kind of show you this part just for the ease of setting things up. Obviously you can name your notebook instance type. So SageMaker is pretty much the pay as you go. So you run these notebooks when you need them, you pay for the amount that you use, and you can shut them down at any time you want. So that gives you the ability to sort of allocate resources pretty much when you want. And of course, it comes with the ability to set IAM roles and encryptions for extra security. And you can even use your Git repositories as an option. But let's go to a notebook instance that I've already created. And you can either use Jupyter or the newer Jupyter Lab environment. I am kind of an old school, so I use Jupyter, the old Jupyter environment. Here, it's if you used Jupyter Notebook before, and I guess for those of you who don't know, Jupyter Notebook is sort of a notebook-style environment for data science type of workload. Machine learning. Of course, you can do regular Python computational stuff as well. It's called Notebook because in a second I will show you. Oh, it's already open, so let me look at this tab. So what you see is a regular notebook. It is a notebook style because you're just kind of writing things as you go along. Either just a text as a way of markdown, or you can use different cells to run different codes. And for today's demo, we have a notebook that we prepared as part of a workshop with one of our customers. This is just predicting hospital spending for different patients. And the data that we get is from Medicare. So from the start, you can kind of see the different cells between, a general text and a code. So in this case, we're downloading the Medicare data set. And let me just run this cell to kind of show you what that looks like. So you can kind of see the output is the output of a code that you're expected to run. So it's kind of going along with the whole process of creating your model. So first we download our data in this cell, and we're going to do some pre-processing. This is a raw data set. And the library that we use is called Pandas. It's a data frame. It's a more of a tabular library that many data scientists use to kind of tabulate your data. Obviously, there's some things that you can do to kind of manipulate the raw data you have into the data that you want to kind of work it into your model. So here, basically what this code is doing is we're going to import the data that we have downloaded onto the pandas, and we call them data frame, is the basic data store of your tabular data. And this last part, so we're making a copy of that raw data, usually because we want to keep the raw data on its own and then use that copy to kind of manipulate, do some pre-processing, do some feature engineering and things of that nature. And this head sort of explains, kind of previews your data for the first, I believe, 10 rows of your selection. So if we run this, and you can already tell I've ran this notebook in the past because you already see the output here. But just to show you that I'm not lying, this is what happens when you run the cell. So it looks like this head is only showing first five rows. I thought it was 10, but I guess the regular setting is to 5 rows. So this is a step to kind of see, what you're working with, what kind of data you're working with here. And from here on, we do some pre-processing. It's more useful to use numerical category for example, state. So that's what we do here. We just encode different values of state into different numerical numbers. And we are also categorizing different, I guess the column called period looks at how much time they were admitted to the hospital before. So, there's different values for that category. And obviously some of these, you kind of have to look into the data prior to doing some of these pre-processing to kind of make sure, you know what your data is composed of, what type of data is there, and if there are any missing values and things of that nature. But being not the best data scientist that I am, kind of skipped some of those steps. But this is just to kind of...
That was something you told me early on too, Young, when we were talking through this, was that, not only is the data and having the data really important, which I dropped a link in to AWS Open Data Registry, but it's also about knowing what questions to ask too and setting out to answer those questions with the data through ML. It's not just about necessarily the data and having the data. It's also knowing how to ask the right questions surrounding that data.
Right. So if you're looking at applying machine learning as a whole, you have some type of business problem that you're trying to solve, and then the next step would be to see if there's data associated with that problem that could help you kind of create that model. And then, of course, the next steps are cleaning that data, which is what we're kind of doing here on this step. And then applying different models to see which model best explains with the data that you get and being able to predict based on that. And I guess I'm kind of going into a little bit of detail on Fiddler, but they're there to kind of make it easier for you to understand, easier for you to see what kind of sort of goes underneath the hood of all this that's being created. So
See,
that was
Young,
sort of
I do listen to you though when you talk.
I got you. Yeah.
I proved it. I remembered something you told me. I promise.
Well, hopefully by the end of this, you'll remember almost all of this. But
all right,
we'll keep going. So some of these, So some of these other cells are basically doing the same sort of a pre-processing stage, if you will. You won't really see the output of these cells because they're not really printing anything, but we can sort of go a little quicker on some of these because they're just basically relabeling some of the categories like claim type into different numbers. And I think if we go back to the data that we have, the percentages are in actual percentages, and we want to sort of turn them into numbers or decimals, if you will. So that is what's happening on this cell, number 6. And I believe this is the same for percentage of spending and state. So it's sort of the same idea here. Again, the same thing for another percentage of spending for nation. And the rest of it is just other methods of recategorizing some of the columns or the features so that it is easier to work with when you're putting in the model. Because obviously some of these strings won't be very friendly when we put it into our SageMaker model, as you'll see. And I guess for this cell number 9, we're dropping this facility name column because we're predicting that this is not really going to have any sort of effect on the predictability of the cost to the patient. And there are some more feature engineering to be done. This is sort of rearranging the column of our output, which is the spending per episode hospital, because the algorithm, I think, requires that your prediction column be in the very front and then followed by your feature columns.
Cool. Maybe we should fast forward through a few more of these data cleansing steps.
So after you do all the cleansing, I think the last part was the range update. We can again run the head function and see that data is more in line with how we want it to look to be able to run this into our code. And there's some more column dropping for, I think, dates, because this is only for 2018. The last part here is just kind of looking at if we have any missing values, which is one of the feature engineering that we kind of have to do. Fortunately, we don't have any missing value. So what we do here from on out is that we now have our data, and we're going to split into training and test set, because we want to be able to have a subset of our data be separate from our training data when we create the model, so that we can actually test on the model itself after it has seen all the training data. So that's what's happening here. The split is based on what you prefer. I think I usually like to do it with 70% training data, 30% split, 30% test data. I think here they did it 85%, 15%. There's no really standard to this. I've seen people do 8-2, 7-3, 85-15 in this case. So then we have our train data and the test data. We output these to our local file, And I guess one more thing I can show you is if we go back to our Jupyter environment, these files that are output to our local file system as you would do if you're doing it locally. So that kind of keeps you with the data that you want to see. So here's where we get to the fun part. So we're going to actually use SageMaker Autopilot to run this data set. And basically, what we're doing is we're importing some AutoML stuff from SageMaker. When we start the SageMaker, we're going to create a job name, which is going to run this whole AutoML pipeline. And if you see the line here that I've highlighted, the single line of code is basically telling AutoML that we're solving a regression problem type because we're looking at a continuous number. And we also want to make sure the criteria for selecting the best model. In this case, we're using MSE, which is mean squared error. Sorry, I almost forgot the acronym. But basically, we're using MSE as a metric, and in this case, we're minimizing so that we're picking the model with the best performing MSE. The lower, the better. And basically, you create a construct and then you fit it with the data that you have. So in 2 lines of code, this is basically going to go through SageMaker's different models, algorithms of regression, run a bunch of model jobs, and then be able to select the best one that they see. So when we run that, it might take some time, and this is a great time for me to introduce SageMaker Studio.
Yeah, I just saw that pop-up window that came up. It said, go look at the experiments tab on SageMaker Studio. I was about to ask, what is SageMaker Studio, Jan?
So SageMaker Studio is our more of a full-on IDE offering. Okay. And it might be better explained if I just show you what it looks like. So while that's loading up, it takes a little bit of time. But what you see is sort of a complete set of tools that you can use to kind of look at different features of SageMaker. So in this case, we have run a AutoML job. So it's telling us, go look at it under experiments. And I believe this tab is experiments. And if we go to describe job, so this is the one that just started, that we have started running. And it'll show you different stages of what is going through at the moment. So right now it's pre-processing. And then as it goes through feature engineering or model tuning, you can even look at the definitions that gets generated, which is not here at the moment, to kind of see how SageMaker is running this whole process. So it's a really nice tool. Obviously, if you want to do some ad hoc, simple notebook workload, it's probably better to sort of use this kind of environment. Just spin up a notebook instance and run your code, kind of see what's going on, and then iterate if you have to. But if you're doing a whole full-on autopilot job or something on a more at a scale, Studio might be the tool to consider, because as you can see on the tabs here, you can kind of upload, you can even link your repository, you can upload different sessions, and you can basically run that same notebook that you see here on here and have everything be visible on one window. So in a way,
Notebooks Plus, right? It's Notebooks plus a bunch of other features, it sounds like.
Right. So you can see the experiments here. You can kind of see you can search other features that you can even ask questions. the endpoints, which we're going to talk about a little bit, will show up here if you're ever deploying your model. And then this is just to show what tabs are open.
Yeah,
But
I
this is
a lot of features.
This is actually going to take a while.
Okay.
And in the interest of saving a little bit of time, we can skip ahead to sort of deploying the model as we have. So I've already ran this model before. So let me actually stop this. So this will throw out an error because we stopped it before it ended, but we actually have a model that has been complete. I just need to copy the name. Just give me 1 second here. This is important because we're going to call out the name of the job that we have already completed. And what this cell is doing is basically creating an endpoint for deployment where you can then use it to make inferences. And this one should run a little quicker. And if you go back to this tab, under the endpoint, it should show up. Yeah, so a new endpoint just showed up. It's the endpoint to the models that's now deployed or is being deployed. And hopefully, I think this actually might take a while too.
Well, we got to get to our friends at Fiddler Labs here. Let's maybe just do a quick summary, and maybe we can revisit this at the end.
So in summary, you've seen how easy it is to use SageMaker to kind of create your machine learning process, from gathering data, cleaning the data, training, in this case, many models all at once with basically at most 2 or 3 lines of codes, and then being able to deploy this on SageMaker from where you can make predictions based on whether it's test data or whether it's some new data point. So that part of it will make your life very easy for you to kind of start your ML journey. But like I said before, you don't really see the inside of what's actually happening and kind of be able to explain. And that's something that's very important for businesses. You have different stakeholders that kind of want to know what's going on, and they might have different levels of knowledge of different models or different terms. So that's where we have folks like Fiddler Labs to kind of help us along being able to explain and have better visibility into your ML workloads and practices. So I guess this is time for Krishna and Manoj to take away.
All right, let me take control there for just a second too before we move on. If you're just tuning in, I've seen the viewer count slowly uptick. So if you're just joining us, this is AWS Howdy Partner. We're here with Krishna and Manoj from Fiddler AI, and we're about to get into their product and how their product can help you work with SageMaker and ML Ops and all those great things. If you have questions, please put them in chat. If you'd like us to explore something, please let us know. We're here, we're monitoring, we're chatting right there with you too. Young just gave us a great kind of intro crash course into SageMaker, which sounds to me like you get a hosted Jupyter environment, you get some of these auto ML features, which are really interesting, and to a cretin like me who doesn't understand ML, sounds like maybe something that I could even work with. And you get this endpoint for hosting your model so you can actually make inferences against your model once it's trained up and ready to start making predictions. So cool. Thanks, Young. Krishna, I'm going to throw it to you now. You want to tell us about Fiddler AI and what you all are going to talk through today?
Awesome. Thank you, AM. Thank you, Young, for an awesome demo on SageMaker. It's really a great platform to operationalize machine learning in production. We have a lot of customers using it today. So Fiddler is an explainable monitoring product. It really takes off where SageMaker has left off. So for example, if you're an ML engineer or a data scientist, you're trying to, build a machine learning model to predict a particular task. Let's say you're trying to predict how likely someone is going to default on a loan, how likely someone is going to get readmitted into the hospital, or how is good, this particular item is for an e-commerce sales purpose. You could really, use SageMaker to create all kinds of different machine learning models with their awesome automated machine learning platform and set up endpoints that you can deploy the model to be served at scale. Now, when you are doing that, you want to know how your model is performing on a continuous basis. How is your model affecting your business metrics? For example, after you deployed the model, are the e-commerce purchases going up or down? How are the loan collections happening for your organization? And similarly, you may have different stakeholders in your company, your product teams, your senior leadership. They may ask you, why is the model performing in a certain way? For example, why was a particular, applicant denied a particular loan request, or why were we not selling these particular set of items, in the last week or so? So when those questions happen, you don't have a good way to diagnose those questions and provide answers to these different stakeholders, and that's where Fiddler comes in. Fiddler is a pluggable platform that you can connect to your SageMaker models very seamlessly, and we're going to show it today, and to continuously monitor their model performance and make sure that they are performing the way that you expect them to be, and also explain how the models are doing in production to a wide variety of stakeholders in your organization. So let me actually share my screen so to give you a brief overview of the platform, and then we can get into demos where Manoj, my colleague here, is going to show you how it integrates with Fiddler. Just give us 1 sec.
All right.
Cool. Awesome.
Got your presentation up. Yeah, you're ready to go.
Awesome. So as I mentioned, Fiddler is an explainable monitoring product that sits nicely on top of a wide variety of modeling platforms, SageMaker included, to help data science and machine learning teams to operationalize AI with full visibility and transparency. Why is this actually needed? Let's look into it. So as many AI and ML teams are looking into operationalizing AI, there is a problem that they are trying to deal with today. That is, they don't have visibility into how the model is working when it's deployed to production. Why is it making certain decisions? And this is actually becoming a problem day by day. For example, if you have seen in the recent months, followed the news around TikTok, there was a whole bunch of news around TikTok having black box algorithms that posed a national security risk for the US, and that eventually impacted their potential acquisition. If you have followed some of the news stories around the coronavirus pandemic, a lot of AI and machine learning teams were scrambling to understand how their models were performing during the pandemic. The reason is when you're trying to train a machine learning model, you use historical data, right? So, and when you see a black swan event like coronavirus, then all of your historical data may not mean for much, right? So for example, if you have created a lending model and using historical data pre-coronavirus, your applicants that are, that may have been affected by COVID-19 pandemic, for example, restaurants trying to apply for commercial loans, or individuals who lost their jobs trying to apply for consumer loans. They may not fit the demographic that your pre-coronavirus sort of data had. And so monitoring how the model is performing continuously is a huge problem today, because every day is a new day, because we are dealing with a shifting reality, right? So as we're still not out of the pandemic, we don't still know when we'll come out of it fully, and so it's very important, if you are building machine learning models in production, that you have this visibility. The third aspect is, because machine learning models take a wide variety of features, or as Young demonstrated, attributes of a particular data set to come up with a prediction score, there can be many hidden biases that can creep into your data. For example, as a society, we know that we are not in a perfectly equitable society, right? And so when we are collecting data sets from the society and training a machine learning model, say for a lending task, or for, let's say, screening an employee application, one needs to make sure that these models are operating in a fair and transparent manner. For example, almost a year ago, we have seen when Apple launched their credit card, a lot of consumers felt that it was discriminating against gender. There was this particular customer that experienced where they and their spouse got 10 times in credit limit difference, even though they shared the same household income, their FICO scores were similar, they were making similar amount of salary. So it's very important for AI and machine learning teams to, understand how their training data set is, understand, whether it is actually balanced, and understand if there is any proxy bias creeping into the model, and to continuously monitor for it. And then the fourth problem that we are seeing is, especially as machine learning is entering into regulated industry, say financial services, healthcare, human resources, it's becoming very important for these companies, organizations, to meet the compliance requirements that are already in place. Otherwise, there could be litigation that, companies could, get into because of non-compliance. So these are some of the problems that I happened to solve when I was at Facebook. I was an engineering leader on the newsfeed team, and where we were building lots of machine learning models for recommending news content to Facebook users. So in particular, my team built this platform that provided these continuous diagnostics into how newsfeed models were performing and recommending content. So one of the features of this platform is this particular thing that you see on the left-hand side. It's called "Why Am I Seeing This?" So this tells you in a very human readable, understandable manner of why you're seeing a particular recommendation on Facebook. In this case, this particular post is appearing in my feed because I'm friends with so-and-so. I'm a member of so-and-so group. I may have liked this person's post more than others. And this post was a more popular post in the group compared to other posts. And so when we built this platform, we saw at firsthand how much it gave us insight into how newsfeed AI models were working. It helped us to resolve questions like, why is the particular user seeing a story like this? Why in an aggregate, why is a particular story trending? Is it really, sort of fake news or, relevant news? All of those things we could diagnose quickly and be able to help answer questions for, senior management, business operations teams that would serve external publishers, as well as our own individual, engineers who are debugging and trying to make machine learning models better so that, they can continuously improve the performance of the models running in production. So with that experience of building the platform, we realized that there is nothing that helps developers to build this type of transparent and trustworthy AI in production today. And we launched Fiddler a couple of years ago, and we were very lucky to have an awesome team. And Amazon Alexa fund recently invested in us, and we are super excited about the partnership that we are striking with Amazon. So the problem that we are trying to solve is that as machine learning models are becoming more and more complex, they are becoming a black box. What does that mean? So, for example, let's say you're trying to operationalize a new lending model in a fintech company. Your business user, who could be a credit analyst or credit or a risk officer, might ask, "How does it work? When would it approve loans? When would it reject loans? How do I know how to trust it?" Right? So this is where transparency is very important. Your engineering team, that is responsible for maintaining the model, might need to know, how do I monitor how the model is performing on a day-to-day basis? How do I debug if systems are working fine? If there is any model performance issues, how do I debug? How do I understand if there is any drift? The distribution of data, has it changed? Is model actually performing the way I actually trained it before, or has it degraded in its performance? And if you have a compliance team that is responsible to make sure that you're building fair and transparent AI, they may have questions around, is this model performing equally well on males and females? Is it performing equally well on different demographics? So there is no good way for these different stakeholders to come and ask these questions and make sure that they can trust the AI model. And once you can actually help them answer these questions, then you can have them adopt your AI and machine learning models much more freely with a lot more confidence in their business use cases. And so this is the question that we are helping solve. So, if you are trying to operationalize machine learning models in production, how confident are you about its performance? Are you sure that it's running the same way that you've expected it when you trained it and launched it? Do you have the visibility about this, that it's actually working in the same manner? Is it biased? Is it accurate? Is it compliant? These are some of the questions that Fiddler is trying to solve. So we have devised a solution that has worked in the past for different teams. So for example, if you go back 10 years ago, when product managers needed to keep track of product metrics and analyze how products are doing, tools like Mixpanel and Tableau came along, right? So you could keep track of how is your business doing and all in Tableau and really answer anyone's questions quickly. And when the whole DevOps paradigm came into picture, to monitor infrastructure and system level metrics, tools like Datadog and AppDynamics came along. Lots of teams benefited from having the visibility into infrastructure performance, system level performance. So now, what about AI and machine learning teams? Machine learning models are becoming a first-class citizen, right? They're the new code that is entering into organizations, and they're affecting all the business decisions and product decisions that your organization could be making. And so how do you monitor these models? How do you know if the model is performing as expected? That is where we are trying to help. We are building a system of record that helps these data science and machine learning developers to continuously monitor these models, to keep track of all of the model inventory in one place, to have visibility into how they're working, and in a visual manner, explain how they're working to a wide variety of stakeholders. So this is how the platform looks like. It's a highly pluggable platform. So we have customers who are building, TensorFlow models or scikit-learn models, PyTorch models, H2O models in production. They could be using systems like SageMaker, DataRobot in actually building and using automated machine learning workflows to build these models and deploy them into production. Especially SageMaker, which allows you to deploy these models on the cloud at scale and pay on the go. And when you do that, you want to monitor all these models, and that's where you could use Fiddler to seamlessly plug in to these frameworks as well as the data sources where these models are getting the data, so that you have complete visibility into how your models are performing in production. And that way you can actually extract full value out of AI, right? So the whole point of AI is to improve your business process workflow, make better decisions for your users, reduce inefficiencies. All of that can happen when your entire organization can use that AI application that you're building in a trustworthy manner. And Fiddler will help you unlock that. Here is the product architecture. If you are a customer of SageMaker, you could be bringing in your SageMaker models, connecting SageMaker endpoints to Fiddler in a very seamless manner. We're going to show you how you do that. And SageMaker itself could be training a wide variety of models. SageMaker supports, TensorFlow, XGBoost, scikit-learn models, so you could actually monitor how those models are working with Fiddler, and you can analyze how the model is performing, and detect bias, detect performance issues, keep track of all the models running in one place, so that you can create reports if it's for a regulatory use case, so that you can give it to your compliance departments. And all of this insights are also available through APIs. So if you want to connect Fiddler to your favorite BI dashboards, where you may have other metrics as well, then you can also bring Fiddler's metrics into your Power BIs or Tableaus of the world, or other custom applications that you may have. The beauty of it is you can actually wire Fiddler on both on-prem or cloud. So a lot of the customers that we serve are, financial services companies that are essentially have a lot of hybrid cloud infrastructure going. So some of the workloads are in the cloud like AWS. Some of them are in on-prem in an old data center. Fiddler can seamlessly work across those things. So you can have a SageMaker model running in cloud, and you can have a Fiddler-like system that's running on-prem and cloud, giving you visibility into how your models are performing on both places. So let's look at how Fiddler integrates with SageMaker. As I mentioned, SageMaker is an amazingly scalable platform to create, deploy, and serve models at scale. And we have a lot of customers that are using Fiddler or also using SageMaker. What Fiddler provides on top of SageMaker is the ability to QA models before you launch them, ability to monitor those models continuously once they are launched, and ability to explain the models, when they're running in production. And that's how you can actually make your AI applications fully transparent, fully trustworthy, and scalable at the same time. This is how Fiddler and SageMaker fit in the MLOps workflow. So using SageMaker, as Young demonstrated, you can do feature preparation, data, sort of feature engineering, train the best possible model using the automated machine learning APIs, and then deploy and serve the model at scale. Where Fiddler can help SageMaker developers is, once you have trained a model, you can use Fiddler to validate it so that you can review it and test it so that it's actually working as expected. This is where you look into the guts of the model and see how it's coming to arrive at a particular decision. And similarly, once you deploy it, you can connect Fiddler to it so you can monitor it on a continuous basis and help you sort of stay on top of model performance. This is actually how it connects within a SageMaker deployment workflow. So typically, as Young demonstrated, in SageMaker, you start with some training data and some ground truth like label data that you have collected, and they're typically sitting on S3 after they are joined together, and you spin up like a notebook, which you will use SageMaker's APIs to do feature engineering and model training. Once you've trained a model, it's persisted back into S3, and now you can actually deploy the model so that it can actually is an endpoint is set up, so you're receiving traffic, real production traffic for that model. And so SageMaker has this really nice abstraction called data capture, which allows you to log your inference predictions into this data capture abstraction. Fiddler uses the data capture to collect all the prediction logs. And so this is basically the basic requirement to connect Fiddler to SageMaker. So you can send all of your prediction logs. Let's say in that lending model, let's say you're trying to operationalize a credit risk model. What you will log is your feature vector and the prediction. The feature vector could be like FICO score, loan amount requested, salary of the individual, and the prediction could be the risk probability of approving a loan. So you will log every time a loan application is processed by SageMaker, you will log a particular prediction log entry into data capture, which is collected by Fiddler, and so that it can monitor it on a continuous basis. Additionally, you can also provide the model endpoint or the model artifact to Fiddler. So this is an optional thing. If you want to explain the model, look into how the model is doing, you can point Fiddler to SageMaker's endpoint API or bring that model artifact into Fiddler as well, so you can probe and debug the model, and as well as provide a training sample that you use the training sample so that Fiddler can, make sense of the model using the baseline data that you trained with. So this is a very simple one-click integration with Fiddler. If you have a SageMaker endpoint, we provide a simple API to monitor that SageMaker model by providing the model inputs and outputs, and we will show you how that works. Here is a customer of ours that's using SageMaker and Fiddler in production very successfully today. So Hired.com is a very well-known recruiting company. They use deep learning models to match resumes to relevant jobs. So if you're looking for a job, you go to Hired.com, you prepare your resume, you upload it, and then their matching engine takes it and matches it with relevant jobs so that recruiters can reach you for a given application. And so here they have successfully productionized SageMaker to train these TensorFlow models and deploy them in production. We have worked with Hired to integrate Fiddler into the models running on SageMaker so that their data scientists can monitor the model's performance. How many matches are happening on a given day? How is the model performing? What is the model's accuracy? Is it actually going down or up, or alert me when the model's performance changes? Similarly, how is the model performing on different demographics? It's very important in hiring to make sure that you are providing an equitable service to your users. You're not discriminating against anything like gender or race, even by accident. So Hired uses Fiddler to monitor bias in their models, as well as explain the decisions to different stakeholders. So because it's a recruiting company, they have this wealth of knowledge of what makes a good candidate. They have humans like career counselors, curators who have built up this wealth of knowledge. And so by explaining how the model is matching the candidates to curators, Hired's data science teams are able to build trustworthy AI applications so that they can deploy these models with confidence. Similarly, they're using some of the explanations to improve the candidate's experience. So let's say when I upload a resume, if I'm not getting enough matches, I might get suggestions to what kind of courses I can do to improve my match rate in the future. And then similarly with recruiters, they basically show snippets of information that help them, here is why we are matching your candidate today for your job request. In particular, they used to spend weeks of time debugging model performance prior to Fiddler. If you are building an ML-based product, your business metrics are dependent on how the model is performing. right? So when your model is not performing well or some bad data is coming into your model in production, your business metrics will slowly shift and you won't know how that is. And this is a very common issue. This used to be an issue even at Facebook. And we used to struggle before that platform to answer those questions. So when you have a monitoring system like Fiddler, what you can do is you can essentially look into, say, let's say matches are going down. Why are they going down? Are match predictions going down? Have they shifted week over week or month over month? What features that they're using have changed over time? All of those questions you can answer so that you can debug things very quickly. Today, Hired.com engineers can debug these issues under a day versus spending 3 to 4 weeks as they were before. So now let's look at all of this in action, and so that you can see how Fiddler helps machine learning teams. Here is a lending model that is trying to predict loan decisions. It's essentially let's say it's as a fintech company, you're trying to use machine learning to approve and disapprove loans. And you're using SageMaker or any other ML platform to operationalize it. So Fiddler can connect to the SageMaker endpoint and get the prediction logs from the data capture and help you monitor the model. So the first thing is, I want to know how many loan decisions are getting approved and unapproved on a given week basis. So this is like a chart that gives me an idea of what's happening on a given week. In the first week of November, about around 80 loans are being approved and similar number of loans are being unapproved. I can also track the accuracy of the model over time. So when you have labeled data coming in, so for example, let's say when I'm getting installment data coming back. So let's say the users who are applying for loan are paying back their first installment. I can then join that data with my predictions to compute the accuracy of the model over time. Secondly, Fiddler helps me to look into drift in models. And so we've talked about how coronavirus pandemic has affected AI and machine learning teams because of the underlying changes in data. And here, Fiddler helps you to keep track of, on average, how are the model's predictions? Where are they? Right. So this is essentially a model that is predicting this thing called probability of charged off. It's a number between 0 and 1 that tells you how likely you're going to default on a loan. So if the number is higher, then you're a risky loan applicant for that fintech company. Now, down below is where we are tracking model drift. So drift is essentially looking at how is the model performing compared to how it was trained in the training set. And it's very important because, as I said in the beginning, models rely on the training set data. They rely on the patterns that they encode from the historical data to predict the future. So when your data itself changes, your models may not be trustworthy. So it's very important to always track your model performance against how it was doing on the training set. And so here in this case, the drift is around 0.2, hovering around 0.2. So which means there is a 20% drift in your model performance. This may be acceptable. This may not be acceptable. It depends upon the use case to use case. Here, I want to see what happened in this spike. So in this 12-hour window, why was the drift actually slightly higher than it was on average? So down below, what we show is all the features that went into the model and their individual importance for the model prediction. So like what are the most like in a sorted order, like what are the most important features, and then their individual drift. How is the feature shifting between production and training? So how is the distribution changing? So as you can see here, there is a feature called interest rate, and you can see here the orange is the training set distribution, the blue is the production set distribution. They are roughly the same, but there are places where there is difference. For example, here, there are some high interest loan applicants in training set, and similarly, there is a distribution difference here. And by combining these two things, we come up with a new metric called drift impact that helps you sort the features that can have a huge impact on the model performance. So according to this, interest rate is having the highest impact on this drift. And because it is also very important and it's having a decent amount of drift. There may be features that have a lot of drift. For example, employee length is having a lot more drift than interest rate. You can see it's about 30% drift. And you can see why it is, right? So here, there are a lot more applicants in the training set across different buckets than they are in production. And so, your drift is quite high, but they are not in the top important metrics. See, employee length is somewhere about number 10 position, but not number 1 because their importance is not very high. So compared to interest rate, employee length is only 0.5% important, whereas interest rate is 3.9. This is where explainability helps you to diagnose the model performance. So by simply looking at these features, one by one, you can set up alerts around this feature drift. You can actually come to this and diagnose model drift issues quickly. So for example, here, let us say I set up a threshold, like alert me anytime the model drifts beyond 20%. And so in this case, I would get an alert for this window. I come here, I can check which features having such a big drift. I can see, for example, accounts open past 24 months. There's some wonkiness here. There are more people applying in production with fewer accounts open than they were in the training set. So I can go and check my logs if this is the case. Is this like any bad data coming through or whatnot? Or I can, ask my business team what's going on. Are there any sort of trends happening and see, and is it actually real or not? So that's how I can sort of stay on top of, model performance. Similarly, I can catch many of these issues in real time at a granular level. For example, as models perform, in production, they're receiving data on a continuous basis, right? And what happens is when you're building these data pipelines or models, there could be code bugs, there could be system errors, could be data issues that could send garbage data to the models. For example, you could have missing values or nans or different type mismatches. So let's say you have a feature that is expecting strings, it is getting numbers, or if it is a feature that has to get it's a salary that has to be between $100,000 to $500,000, but it's getting values like $1 million or 50,000. That is like not expected, or that is getting missing values, like it's essentially the data is not being sent at all because some other process upstream has stopped writing the data, right? And these are all very common things in infrastructure. We see these things often happen, but when they happen for your models and when those critical features are missing, then your model predictions can go haywire very quickly. So it's very important for a machine learning engineer to monitor these events and have an eye on top of which features are having these problems. We call them violating events, and so that you can go and fix those data pipelines. In this case, Fiddler automatically shows you what are those features that are having these violations, which kind of violations are they having, how many violations are there, so that you can go and fix them. And so you can look at them feature by feature, or you can only look at individual features if you want to, and understand what's going on within your model performance. This is a very quick way of catching things in production, and very useful tool to have in your MLOps workflow.
Krishna,
any questions? Yeah,
sorry
please,
to interrupt.
Yeah.
We have a question. Yeah. We're talking about this having visibility and stuff like that. So what is your point of view regarding, businesses, consumers, or regulators that call for more accountability and transparency in some of these AI solutions? And, do you know if they've been able to kind of tackle that problem? Because transparency is always an issue, for certain businesses when you're discussing, AI or ML related topics. So that's a question around that. If you have any thoughts on that.
Absolutely. So AI is a very complex topic for people to understand, right? You know, if you are trying to bring AI into your business workflow, let's say you're a credit risk team in a bank and you want to move towards machine learning to make lending decisions. Immediately, your business stakeholders, your credit analysts, your credit risk officers, your lending officers will all want to know what's going on, or your regulators, your auditors inside the bank might be interested in answering how is this model going to work? Is it are there any weak spots in this model? When is it going to reject loans? When is it going to accept loans? It's a very natural tendency for humans to ask questions when there is a black box presented, right? So, and I'll get a little bit philosophical here. Humans as a species, we are able to scale so much because, we are able to scale trust. We rely on abstractions on every day. I go and, purchase something on Amazon.com with the trust that it's going to get delivered in a day or two, right? And so, and that abstraction keeps me, do other things. And similarly, if I don't know that if Amazon is not giving me tracking into when this item is delivered, it's just a black box for me. Similarly, if I'm like an institution that is operationalizing AI for any use case, whether that is a regulated use case like lending, or a non-regulated use case, for example, like e-commerce recommendation. I want to know how the model is working. Why is it predicting a certain item to me? Why is it actually improving our business metrics or not improving the business metrics? And that level of transparency is like something that makes every organization more efficient, more compliant. And by knowing these reasons, the data science and machine learning teams can build better models over time. If I know what's going on with the model, if I can debug the model, if I can fix operational issues, I can improve my model and my ML application over time and improve its performance over time. So it has multifaceted benefits. And we see ourselves as a platform that essentially, as I said, here, catering to helping data scientists cater to all of these questions, helping your business users build trust, helping your customer support teams to help answer complaints on your ML products, helping your IT operations team to monitor those models effectively, helping your compliance teams to, understand how the models are working. So that is our vision, is to provide the data science team a tool that they themselves can use, but also they can bring their other organizational stakeholders also to increase the transparency. And this in turn helps them, right? This helps the data science team to sell their models, operationalize them quickly, and get that business impact. The whole point of doing machine learning is to increase that business process efficiency and radically build new kinds of applications, and those are the values that get unlocked when you have this transparency and visibility. Hopefully that answers the question. Happy to follow up. So here, as part of this, here you can monitor the feature data integrity, data quality issues. The nice thing about this is, unlike some traditional data quality monitoring, the developer, the machine learning engineer, does not have to set up any rules. Fiddler automatically configures these rules for you, looking at your baseline data set. If you give us your training baseline, by looking at your training baseline, we automatically come up with like what makes like a type mismatch, what makes a missing value violation. And so that you can get this thing like without setting up any complex rules by yourself. Similarly, if I may want to look at, outliers or anomalies coming into my feature data and also coming out of my model, right? And this helps me to understand how my model is doing in production overall, address any challenges. So here is the model running over a week, And this is like the band of like what we call quote unquote normal prediction. So it's in that 1 to 99th percentile. And there are some outliers marked by these models. So most of these outliers are extremely low risk people. So I'm curious to know what makes this person a low risk person. So I can click on that and you can actually see here. So for example, this person applied for a $15,000 loan amount. The loan was priced at 11%. He has been on an 8-year job tenure, is on a mortgage, and then he is making, quite a bit of income, right? So $58,000 income. And actually look at this other case. This is actually another curious case. This person's income is only $93,000. So while this person is getting, $500,000, his risk is so low, but this person is getting only $93,000. This person's risk is so also low. What makes these two people considered by both the model as low risk? So let's investigate. This is where explainability comes into it. So when I click on that light bulb, Fiddler generates this nice dashboard that helps you look at, first of all, the model prediction, and then the impact of the features. So there are so many features that went into it. It is only showing there are about 60 features in the model. So it's picking up the top 10 features and helping you show which features are having the highest impact. In this case, I'm interested because this is such a low-risk loan application. I'm interested in things that are bringing down the risk. So as I can see, annual income is about $500,000. It's at the top end of the spectrum. And you can see its impact is actually negative 20%. And the second most important feature is FICO score. That's also a little higher. 755 is a very good high FICO score. And that's also dropping the risk prediction by 6%. So now I can reason about, I can ask questions to build intuition with the model. So, okay, my question is, what if this person was making half of that salary? So let's say he's making only 29,000 or 290,000. When I make that change, Fiddler automatically recomputes the prediction and I can re-explain it. And when I made that change, now you can see that this impact went from negative 16% to negative 12%. And similarly, I can ask, what if this person had 10 accounts open? As I can see, when this happens, the risk increases slightly, but it's still within the bounds. It's very low. It's still very low. And I can see when I move from 1 to 10 accounts in the past 24 months, this particular feature is now becoming a positive contributor of that risk. So this helps me build intuition, help customers that answer questions that they may have to, especially this is useful when you're answering a customer that's going to get rejected. In this case, this person is so low risk that he's going to get accepted. But it also helps me diagnose. So for example, this other person has only like $93,000 in salary. Why is that? Let's try to find out. So it turns out actually in this case, the salary is not on one of the top variables. There are other things in play. First of all, look at the FICO score. It's about 820. It's on the highest band of the spectrum. That's actually getting a 9-10%. And then there is this feature called BC limit. I'm expecting this is some credit limit that he got approved, and that's actually very high. He has a very high credit limit, and that's actually also reducing the risk because he's only applying for a loan amount of I think it was $15,000, $10,000. So as a result of which, the model thinks it's a very low risk use case, and you can actually underwrite this loan, right? And so this is how you can explain the model live when it's running, when it's making predictions, and you can essentially set up alerts for all of these metrics. So that you can get alerted when your model drifts in predictions, when you have violations for your data quality. You can set up alerts so that your team members can get notified on various different things, PagerDuty, Slack, email, so you can actually come and resolve these issues. So while I saw that, there's an interesting way that you can also use Fiddler is to be able to do model audits, when you want to, go back in time and investigate why some things may have happened. So let's say I want to run against my last week's production data, and I can do like some queries. Let's say I want to look at loans that were approved, with loan amount greater than $10,000 and a risk probability greater than 0.3. So here, Fiddler helps you look into each of these loans on a case-by-case basis by doing these type of queries, and then look at. So I'm particularly interested in this particular person. He's got a 44% risk probability, and we may have approved this person's loan. I want to know why. And so when I explain this here, it turns out that this majority of this thing is coming from the interest rate that we priced him at. So 34% is what we priced him at interest rate, and 24% is what we priced him, and that's contributing 34% of this thing. And so now, if I had priced him normally at 12% interest rate, the risk probability drops to 0.24. So I can understand, why this particular loan application got 44% risk probability is mostly because my team priced it at for 24%. If I made it more normal, then his risk probability is within line for me to approve it. So I can actually look at it. The only negative factor that is actually, there are a couple of negative factors. One is he has too many accounts that he has opened in the past 24 months, and his FICO score is also low. Those are the two worrying factors for me as a credit analyst when I'm looking at it, and I can ask the team, what they thought of it and how they approved the loan when they're looking. This is how you can actually audit, what happened in the past, going back and reproducing it. And the nice thing about it is this works on any kind of model. So far, I have showed you a lending model that is operating on a structured data. With SageMaker, you can build NLP models. NLP is on the rise today. Lots of people are deploying, lots of very interesting LSTM, BERT, lots of very interesting models. It's a very, very interesting space to be in, whether that is sentiment analysis, question answering. Here is an LSTM model that is running on movie reviews data to classify movie sentiment. Now, I want to know how the model is making a particular prediction and what factors it is making, what words it's actually are responsible. And I mean, if you are using Alexa, I have an Alexa at home. If I'm an Alexa engineer, I'm also interested in this type of use case, right? So let us say Alexa might be doing, has a model accuracy of whatever, X percentage, right? So let's say it's doing well on certain sentences, it's not doing well on certain other sentences. I want to know why the Alexa model is performing the way it is. And so, here is a tool to diagnose that. So in this case, this movie review got a 0.018 sentiment score, and I want to know which words are contributing positively and which words are contributing negatively to that sentiment score. So this helps me do various different things. It helps me, understand the model. It helps me if it's dealing with any biased or politically correct words, right? It helps me to understand, how the different words are coming together, what makes the model, what is sticking, what is working for the model. So in this case, these are the three words that are dominating, that are having a huge negative impact. And I can actually do one thing. So I can fiddle with the model. This is why we named Fiddler, because you can actually fiddle with these inputs. So you can actually remove this thing, and you can actually rerun it, and you can see like the prediction score actually, instead of going up, it actually went down even further because the model found other words like stinker and for some reason producers is a negative word in the IMDb world. Maybe it's an associated negative context. So you can keep doing these things. You can actually remove even that sentence and try to re-explain it. And now the model score jumped up almost by a factor, but it still has some more negative features. For some reason, Glenn is a negative word. And you can also add words. For example, you can say, okay, I really, really loved the movie. So now I'm trying to do some adversarial testing, right? So let's say, what if like the user is trying to put some good words and bad words together? What would happen? So when that happens, the model picked up loved here. Now I can actually try to see what if the user actually puts this not at the very top, but somewhere at the very end, what will happen? So let's say I really, really loved the movie. So when that happens, the model score jumps up even higher because it for some reason it actually attributes higher positive score when it's at the end. So this is how you could actually reason about how the model is performing on your given data set. You can also explain things on aggregate, which is something that I'm going to show Yeah, sorry. Any questions? Cool. So so now that once I showed you that how you can explain the model on a given data point, here is something I want to show how you can explain the model on multiple sets of data points. So this helps you evaluate and validate and analyze the model. First step is I have a churn model that is essentially making churn predictions. It's essentially working on, this is how the model's accuracies are on train and test data. Here's the confusion matrices. This is all nice. Now I want to explain it. So I go back to that explain page that I showed you. I'll just like revisit. So in this case, I'm looking at users that are churning with a high probability. So in this case, this user is churning with a 75% probability. Now, this is a use case where a marketing team might want to know what are the things that they can do for users that are high churners to bring them down to a low churn. So this person is churning with a 75% probability. What do we make him come down to 50% probability? So you can, for example, you can say, okay, let's try to, let's say, what if we gave him $20 discount, right? When I do that, I can re-explain the model. Here, the prediction already dropped. And so this factor got neutralized, right? So it has zero impact. You can say, okay, what if I move the contract from month to month to 1 year? When I do that, this actually drops quite a bit, right? And you can see, for example, here, this one change actually had a 50%, almost 50% impact on the prediction. But my sales team might say, hey, like this is a very difficult thing to convert a month-to-month user to one year contract. Let's actually not do that. So I go back to my previous setting. So it's month-to-month contract. Now I can hunt for other variables. Okay, what if I give this person a tech support? What if I give this person, some more features like online backup, online security? And when I do that, this person's prediction changes, shifts below 50%. And all of the changes that I've made, my discount for monthly charges, my upsell on product features have all resulted in reducing this person's churn probability from 75% to 47%. Imagine this type of insight being available for marketers, and they can actually, take that action. This is how the data science teams can, influence their business stakeholders by providing the transparency. And this entire thing can be exported over an API. If you're, for example, integrating your models in other CRM-like systems, you can actually expose these insights into, say, Salesforce or HubSpot, so here is like a very simple way of exporting. Here is like a simple human-readable explanation that packages this entire thing into one simple sentence that a human can consume. And this can be just exported out into your Salesforce or into your HubSpot so that your marketers can, when they're going through opportunities, can actually look into what's going on. Another way that we help you understand the model performance is to look at global insights. This is important for various different things. You may want to not only understand the model on a given data point, but more on a holistic scale, like on groups of data points. Here is like a churn model that is, performing, with decent accuracy that I showed in the past, but I want to know how it's performing on segments of population. Let's say I get a complaint that, hey, our users, female users are churning a lot more than other people. What's going on? How is the model doing across them? So here is, you can actually run this query. This looks like SQL. This is a very interesting way of using SQL for doing model analytics. So when I run this query, what happens is it's running the model on my data set, and it's filtering the genders with female and probability, whatever. You can pass arbitrary predicates here. All of these type of predicates, all of the columns that are available in your table, you can pass them. And so here are the users. About 255 users in the telecom data set qualify this query. About 255 females are churning with a high probability. Now the question is why? So that's what it on the right hand side is showing. So it turns out that a lot of these users the contract is one of the dominating factors for them. They have, most likely they're on some month-to-month contract or something that's actually driving their churn much higher than the rest of the population. It also turns out that monthly charges is not such a dominant factor for them. This is a very interesting insight, and it's counterintuitive for me, right? Why is monthly charges, usually I expect someone paying high monthly charges to churn high, but in this case, this is actually not true. So I'm interested in digging deeper. So here I want to create a scatter plot that can analyze this data further. So now here I found out that when I plot monthly charges versus churn on this female high churners, I see an interesting insight. A lot of the female churners are already paying $70 or higher in the data set. And so what's happening is the data set, there's no signal for the model to capture. So it's not as important a variable as it is for the other the data set. This is a very interesting insight, right? So for example, I can actually remove this predicate and rerun the query, and I can see that my distribution, I have to update this plot. So I can see that my distribution is actually more even. I have people with both low monthly charges and high monthly charges. It's pretty even. And there's probably a better way to look at it. I can also show distribution of monthly charges. So you can see like they're kind of even distributed. But now when I actually include this predicate, turns out that most of the users are actually paying higher than $70, and so the model is not able to discriminate this thing. So this is an interesting insight for me to share with my business team. Hey, this is how it's working, and you can also go and try to figure it out if you need to improve it. So that's kind of how you would use the system to understand how it's working on different data sets and like look at segments of users, why they're churning, what's causing them to churn. And you can not only create these plots, you can actually pin them to different, create like a dashboard out of these plots. So Fiddler supports like a nice little a dashboarding capability where you can create all of these charts visually to share to your different stakeholders so that they can come and explore this further. So that's kind of in a nutshell how the product works. We take your data and our model artifact and help you provide these visual insights so that you can help understand how the model is working. Now let's look at how this happens in the context of SageMaker. So
yeah, I wanted to stop you real quick, Krishna. I mean, that was you unpacked a ton of features there. That was really dense, but it was amazing. So, I mean, some of the things that I saw, again, as an outsider, ML, but things that I think are really compelling, being able to change some sample data and see how it performs with the model all through a dashboard. That's really powerful. That's super cool. And then generating like from a SQL-like language graphs and charts and ways to visualize data to see insights that you necessarily wouldn't get just by looking at the data. Both those things are really, really cool. I think very compelling about Fiddler. I wanted to give a recap too for everybody who's just joining us or who have joined us in the middle. We're here with Krishna and Manoj. Young and I are here from the AWS side. They're here from the Fiddler side. Krishna just gave us, I mean, like an insane deep dive into the product. It was so great. And I think we're about to jump to you, Manoj, right? Is that where we're headed, Krishna?
Right, yeah. So now what we will show you is, so far what I've demonstrated is the Fiddler's generic product features. Now Manoj is going to show you how you can connect Fiddler to in with your SageMaker models in production and get all of that value combined with SageMaker.
Before we jump into that, there's another question, just a quick question. Can you describe how your algorithms relate to some of the open source explanation methods like SHAP and LIME, for example?
That's a great question. So we have productized Fiddler on a class of explainability algorithms called attribution-based techniques. So attribution-based techniques do not, there is a difference between attribution-based techniques and non-attribution-based techniques. Attribution-based techniques rely on only probing the model with different counterfactual data and understanding the observations in the model and attributing them back to the features that you have changed. So for example, let's say I have 3 features, credit score, salary, and loan amount. And using that, I'm predicting some risk probability of the loan application. Now, attribution-based methods like SHAP fiddle with these, essentially change, perturb these features and look at changes in my risk probability and attribute them back to these features. Lime does not belong to this family. So Lime builds a surrogate model. So within attribution-based methods, we have a productized SHAP, but we also invented our own explainability algorithms using the original Shapley value. So Shapley value technique that came in the 1950s is actually the mother of all attribution-based techniques. And so this was invented by this person Lloyd Shapley, who was awarded a Nobel Prize for creating this attribution-based mechanism. He was inventing it in the context of game theory, and so now it's found application in machine learning. And so SHAP is one incarnation of Shapley values. We have our own implementation called Fiddle, which essentially is a proprietary technique that we have developed in-house. We have a paper that's out. We actually received a Best Paper Award at one of the AI conferences for this paper that we published. And along with Shapley values, there is various variants of it. There's another technique called integrated gradients that essentially relies on an Aumann-Shapley value-based technique. It's a slight different modification that works very well on deep neural networks because one of the problems with SHAP is that as you add more features, it slows down because it works in the worst case complexity is exponential to the number of features that you have, and so integrated gradients helps address that part for deep learning models. And so we have productized that. So Fiddler comes with a wide variety of explanation techniques, some custom, some open source, and that are available for the developer to choose.
Cool. So Manoj, no pressure, but we've got about 30 minutes left. So Krishna took all your time, man.
No, I can make it quick. So are you guys able to see my screen?
Yes. Yeah, you're up and you're ready to go.
Yeah. So I have 2 examples. One shows like how you can like very easily integrate with SageMaker, like in a very quick and easy way to start. And then there is another one. The second one is like much more complicated and like how you can like pull a model from SageMaker and upload it to Fiddler and then get explanation. So I will show the first one for the first example. Here, so this is a SageMaker notebook, like a typical one. And then you can install Fiddler client onto it. And then you can call an initialize method on the Fiddler to set up the Fiddler connection to the Fiddler servers. So that's the first step. We can run it. I have put all the security and like the endpoint information in a fiddler.ini file, which is in the same directory. So that knows where to connect to the Fiddler. So the second step is like we are going and pulling the data from the SageMaker's log. So SageMaker write the logs into S3. So it writes all the input to the model and the output from the model to S3. So this call goes and pulls the data from S3. We have written a simple util method that samples and then picks up how many number of data points we want from the log. So right now I'm asking for like 2000 lines, and then it completed in a few seconds. So once we get the logs, we can convert that into a data frame. So the one thing about the logs is like the log doesn't have the names of the variables, the input feature names and output names. So we need that to provide that names to the API. So here are the feature names, and this is the output name. And then I can create a model a data frame out of it, right? You can actually see how the data frame looks. It's fairly straightforward. It has like 6 features, and then 2,000 rows that we pick from the log. So once you have that, you can set up a project in Fiddler. So let's run that. It either creates a project if it is not there, or it uses that project if it is already there. Just a few lines of code, and this is all you have to do to register your model into Fiddler, right? So you just point to the data frame that you loaded from data capture, and then you can register it onto Fiddler. So it's just an API call. So it's like create model from production log, and then pass in the project name, model name, data frame, the feature names and the output names, and the type of the model, which is like a binary classification. So we can run it, and then it just validated stuff and then created it. It's lightning fast. So once we created it, it's available now on this particular URL. So we can go down and then see the model right here, right? So this is the one that is created, the launch status one. We have it open here. So you can take a little bit to load it. So that's the model that is created from the SageMaker log, and it shows you all the input features, what the outputs are. And one thing we can do is you can play that event back to Fiddler from here. So, I don't know what happened here. Oh yeah, so now it's sending. I think it took a while to deploy that model. Now it is sending the monitoring events to Fiddler. And then once we can come into Fiddler, you can see, go to the monitoring law side, and then you can see the drifts and other things that Krishna showed you. So all that detail is there. It's just a simple API calls to pull the log from the SageMaker S3 dump, and then push it to Fiddler, and then you can see all the data drifts and data integrity changes, outliers, and stuff like that. So that's a very easy way to get started. One thing that is not there is the model is not pushed to Fiddler. It's just the logs that is pushed. So now we can see the second example shows you how you can actually push the model into Fiddler. So for this is a little more complicated, where we have to create a model first in SageMaker. So as Young said, right, showed you in the beginning, we are first initially creating a model. So it's initializing all the parameters, and then loading up the data, the test and train data from S3, and then it's training a model here. It's using an estimator to train this. It may take a while for training, so I bypass this step right now, and then it's setting up. Once the model is trained in this step, it will create a tar file containing all the artifact in S3, and it's dumped at this endpoint. So we'll just go and pull out the tar file from the S3, and then get the pickle file out of it. That's happening in this step. And once you do that, we have to set up the data capture things where we want to write this log to, right? Like the S3 locations where we want where we want SageMaker to write the logs. And then we'll go down and then do the deploy. This step also takes a bunch of time, because it need to bring up a new machine and then set up an endpoint over the and then set the data capture on it. So I have done it already. So it takes like 5 minutes or so to set it up. So these are like the standard SageMaker steps that you follow to create a model and then deploy it. Once we did that, it's pretty easy to move that model into Fiddler. So we like the old example, we initialize the Fiddler client. We create a data frame for the training set, and then upload the training set to Fiddler. Take a bit, so it's uploaded, and then it creates a the schema for the model. Based on the schema, the data set that we uploaded. And then we write the package.py, like the glue code that calls this into this model pickle file in these 2 steps. And then once we did those 2 steps, we are ready to upload this model into Fiddler. So it's once we uploaded it, we can try it out and see whether the model actually got deployed. So I'm just testing it out with like a sample input and then see how the predictions are happening. And once we have deployed it, we can start sending events to Fiddler. So it starts sending the events from the data capture log to Fiddler. And to make this process automatic, we can like set up a Lambda that pulls the data from S3 logs and send it to Fiddler. So I have set that up in here. So this is where like the files are written in S3, and then I have written like an Lambda that pulls the data from the S3 and then like send it across to Fiddler. And then we can see in the monitoring that like it's actually sending the logs. Probably takes a little bit to start sending. Yep, it is sending.
So is this a common, I guess, architectural design sort of involving Lambda to kind of automate the use of Fiddler?
That's one easy way that we have found. So like when you can write a Lambda that just pulls the logs from S3 and then you can write it. Another option is like you can listen to a queue, and the S3 can publish the events to queue, and then like you can listen to the queue. That's probably another option to do.
Fiddler also supports a publish API call. So if you want to call Fiddler's API, like from your model service, we also support an API where you can publish events from your model service. That's SageMaker or a custom model service.
Yeah. So once you start publishing the events, you can see them, see them here. And as like Krishna showed, like you can do the explain because like now we have the model with us, right? Like we have pushed the model pickle into Fiddler from the notebook, and then all the things that Krishna showed now works on Fiddler for that SageMaker model.
So if teams don't want to push the model in the form of a pickle file, they can also point Fiddler to the SageMaker endpoint. So in that package PY that Manoj showed, you can essentially write essentially where to call your where to call your SageMaker endpoint, and then Fiddler will essentially call your model as if it's actually pushed to Fiddler. Instead it's sending those calls over RPC to the SageMaker endpoint, and you won't know that.
Yep. I think, yeah, that's all the code I have.
Yeah, so this is essentially how we are seeing people who are using SageMaker use Fiddler. Either they can do a simple prediction log integration like Manoj showed, or you can do a model plus prediction log integration, whether that model is physically living in Fiddler or physically hosted behind a SageMaker endpoint. Both things work. And the benefit is you get this full visibility and explainability of your models in production.
Yeah, and we have this demo hosted in GitHub, so people can take a look and try it out themselves.
Absolutely. And if you're interested in trying this product out, we have a limited trial that's going on. So feel free to sign up. Go to our website and click on a sign up for trial button, and we are happy to work with you on that.
Yeah, I dropped that link a little earlier, and you actually read my mind, Krishna, and thank you for that wonderful demo, Manoj. That was awesome as well to see it in action and how easy it was to drop these things in to your already existing workflow. But you read my mind, Krishna. I was going to ask you, as we wrap up here and kind of start getting to the end of this segment. What would be your advice for somebody, who let's say somebody came and watched the show today and they had never heard of Fiddler, maybe they, have done some ML, maybe they're looking for something exactly like Fiddler. What would be other than signing up for the trial, what would be your first piece of advice to them?
Yeah, absolutely. So, see, I think we are in this midst of AI and ML revolution, right? So every company, big or small, is trying to adopt these powerful decision-making technologies into their products and business workflows. Now, one of the most challenging things is to operationalize AI in a trustworthy manner. That is a very, very, very hard problem. And where Fiddler helps you is by providing complete visibility into how your models are performing, you can actually accelerate your AI adoption in your business workload. Because once you understand how it is working, once you're able to explain how it is working, once you have visibility into how the AI is working, then your teams, your management, your product and business stakeholders will have more confidence, will give more buy-in for you to adopt AI. So that is number one. Number two is you can resolve production incidents very quickly. So as you're deploying machine learning models, as they're taking on a lot of all of your business decisions, you may want to debug those things. You may be pulled into questions, right? Why is this not working? Why are the model associated product metrics going down or up? And so debuggability and being able to diagnose those things is going to be important. Number three is, as an organization, it's becoming extremely important for companies to build, responsible AI, to make sure that they're being very purposeful in curating data sets, being able to understand, fairness aspects of the data, their imbalance in their training data. And so Fiddler helps you to uncover those, aspects within your data early on when you're doing model validation, but also monitor it continuously once you deploy the model to production. So think about Fiddler as a sidecar in your MLOps workflow. You need a system as robust like SageMaker that will be your runtime, where you're hosting your models, running at scale, on cloud or on-prem, where you're essentially deploying this at scale, right? But you also need this insight into how the model is performing, where are the problems happening, why is it making certain decisions, how are the model decisions going to happening all together in one place. And that's where Fiddler helps you, gives you that visibility so that you can operationalize AI like with full transparency. This is a benefit that I have seen first class when I was working at Facebook. And without the system, we didn't have a lot of insight into what's going on. And this is the reason why I built Fiddler, because there was not much out there that people can use right off the box to monitor and explain their machine learning models running in production in a seamless manner.
That's a great answer. I love that answer. Cool. So, Young, what do you think? any parting thoughts on Fiddler? I know this is your arena, man. This is you were.
Yeah, I mean, I learned a lot, just like you, AM. There was a lot of information to unpack. As somewhat of a, I don't know how I would label myself, ML practitioner, I guess, of interest, but with lacking that sort of knowledge to do it all myself. I think this is a great tool to kind of have that deeper analysis into how features affect your model. The drifting is great. I mean, I know that it's a real problem into a lot of ML operations to different folks out there. So I think this is a very useful thing. And looking from the UI side of things, it looked to be a very useful, user-friendly solution. So I mean,
Yep,
I mean, I might give it a try myself.
Awesome. Yeah, I'd love to set it up. You play with it for sure. And now and I think we have really worked hard to integrate with SageMaker, so it's very seamless. It's as seamless as it can get if you're a SageMaker developer to hook up Fiddler. So if you're deploying models in SageMaker, talk to us. Be glad to help.
Cool. Yeah. Go sign up. Go check out that free trial link. Manoj, anything you want to add to the end here as we wrap up?
No, that's it. Yeah, it was nice, talking to you guys. Thank you.
Yeah, thank you both for coming on. Definitely go try out Fiddler. We have a few housekeeping things here from the Howdy partner side. Today is our last regularly scheduled episode. So if you tune in on Wednesday or Monday following for the next few weeks, you won't find us. We won't be here. But keep an eye out for Howdy Partner at reInvent. We'll be doing some special shows during reInvent, but also you could catch us during reInvent during our normal time, Mondays and Wednesdays at 2 p.m. for some special shows, not our normal format, on Twitch right here, twitch.tv/AWS. Go sign up for Fiddler, try it out, and get that feedback to Krishna and Manoj. I think, with such wonderful demos, it's the least you could do, right? Go try it out.
Awesome.
All right. Well, we're going to sign off. And Krishna, Manoj, Young, thank you all for being here with me. This was a great episode. Really appreciate you all.
Yep. Thank you so much. Thanks for the opportunity. And thank you.
All right.
Thanks, guys.
We'll see you soon.
Bye-bye.
Bye-bye.